Okay, so let's go to the week 5. So welcome to this online course. So this the descriptive statistical numerical measure, and this is the master course. The course name is the quantitative research method. So we are going to the week 5. Okay. So I'm instructor Chong Guang Ho. I'm from the Kunshan University. Okay. So today's topic is the first one: measure of location, measure of variability, measure of relative location, and the detailed outliner, and the exploratory data analysis, and the measure association between two variables, and the weight mean, working with group data. So today we will cover this topic. Okay. So the numerical measure. So numerical measure. This is the previous week we already we talk about the descriptive statistic, and we talk about how to run the SPSS. So let's talk about the numerical measure. If the measure are computed for data from a sample, they are called sample statistic. Or second one, if the measure are computed for the data from the population, they are called population parameters. A sample statistic refers to as the point estimate of the corresponding population parameter. Okay. So today we will talk about the measure of location, the mean, median, mode, and the wage mean, geometric mean, percentile, and the quartile. Okay. So this is the about the statistic. And now we it's very easy if we use the SPSS software. They can solve this kind of question. Okay, what's the mean? Okay, mean is the simple is we call the average. Okay, perhaps the most important measure of location is the mean. The mean provides a measure of central location. The sample mean is the point estimate of the population mean mu. Okay. Okay, so the mean of a data set is average of all the data value. Okay, so that is the same as the average. Okay. Okay, the sample mean, we can see we can see the n is the sum, the number of operation in the sample, and you can see the sum of the value of n operation. Okay. So another one, population mean, or is just different than the sample. Is the sample mean and the population, and you see just the sample size. Is maybe one is sample, another one is population. Okay, so later we will use this sample run in the SPSS. So this is the one example, is the called apartment rents, and the question is the 70 efficiency apartment or rendering sample in a college town. The monthly rent for this apartment are listed below. So this table is show the 70 apartment, and maybe they charge 1 month for the rent. Okay. So the mean is the average. So we can see the total. Total is and we divide by the 70 because have the sample size is 70. So we can get the sample mean. Okay. And the median. What's the median? The median of data set is the value in the middle when the data items are arranged in a ascending order. Ascending order, you must careful. Ascending order, whenever a data set has its value, the median is preferred measure of central location. And the median is the measure of location most often reported for the annual income and the property value data. Okay, a few extremely large income or property value can inflate the mean. Okay, and the median is the middle value when the variable value are ranked in order, and the point that divide a distribution into the two equal halves. And when data are this in order, the median is the point at which 50% of the cases are above and the 50% below it. So this is the 50, the fifth percentile. So because the fifth is the half and half. Okay. So you can see this table. We have the 7 operation, and we need to rank order. Okay, so this is the ascending order. So you can see the middle one is 19. Okay, the middle value. Okay, and the another one. This is because this is the even operation, even number. So because A we don't have the middle one, so maybe we can call the average, the two middle value, 19 plus 26 is divided by 2. Okay, so this is the 22.5. So you can see the first example, this is the R number, and the next example is the even number. So it's a little bit different. Okay, and the apartment rent, the median is the $575. So we need to have ascending order. Okay, so you can see this ascending order. Okay, so now maybe you say, oh, this is not very easy to if you have more than 100, or you need to do the ascending order. So but now I have the SPSS, this kind of software, they can do for you. You don't need to put in the ascending order. Okay. Oh, another one is the trimming mean. Okay. Another measure sometimes used when a trimming value are present is the trimming mean. It's obtained by delete a percentage of smallest and the largest value from a data set, and then compute the mean of the remaining value. Okay. For example, the 5% trim mean is obtained by remove the smallest 5% and the larger 5% of data value, and the compute mean of the remaining value. So this means the 5% trim is the remove the smallest 5% and remove the largest 5%, and they compute the remaining value of mean. Okay. Okay, another one is mode. The mode of data set is the value that occur with the greatest frequency, and the greatest frequency can occur at 2 or more different values. Okay, if the data have the extremely 2 mode, the data are by mode. If the data have more than 2 mode, and the data is a multiple mode. So you can see this apartment rent example. you can count the number. You see the $150. They have 7 times. There's more than other number. Okay. So you can see this is the 550. So this, and the wage mean, in some instance the mean is computed by giving each operation a weight they reflect its relative importance. The choice of weight depends on the application, and the weight might be the number of credit hours earned for each grade, as in GPA. The other way means computation quantity, such as pound, dollar, or what value are frequently used. Okay, so this is the wage mean. So you can see it's the different, a little bit different the mean. Okay, sum of the weight data value and the dominant. Okay, sum of the weight. So this is the example. Okay, so the wage mean is the. So here we like to know the average wage we pay the worker he employed. This below category worker employed along their respective wage and the total hour work. Okay. So you can see he do the 21.6 plot 120. Okay, so the 8, the XSI plot WI was okay. So is the WI. Okay. Okay, another one is the geometric mean. Geometric mean is calculated by finding the n root of the product of n value. It's often used in the analyze growth rate in financial data. Okay, and the issue apply anytime you want to determine the mean rate of change over several successive periods. And other common applications include change in population of species, crop yield, population level, and the birth and death rates. Okay, and the geometric mean. Okay, so this is the rate of return. Okay, so you can see the growth factor. X1, X plot X2, plot Xn, and you can see it's the formula. Okay, and the next one, the percentile. Okay, percentile provide information about how the data are spread over the interval from the smallest value to the largest value. Admission test scores for college and university are frequent report in terms of percentile. Okay, so the p percentile of the data set is the value such as at least p% of the item take on this value or less, and at least 100 minus p% of the item take on the value of more. Okay. And this is the average of the data ascending order in the computer, the location of p percentile. And this is the formula. Okay. So you can see this sample. You want to know the 80th percentile. Okay. So you can see the P is 80 and the N is 7. So this number, the 56.8. So this means the 56, the value plus 0.8 times the difference between the 57 and the 56 value. Okay. Okay. And the next one is quartile specific percentile. First quartile is the 25th percentile. Second quartile is the 50th percentile, the median. And the third quartile is 75 percentile. Okay, so the third quartile. Okay, so this is we can see the formula, and in SPS we can do this very easy. Okay, so another one is measure variability. Okay, so it's often desirable to consider measure of variety as well as measure of location. For example, in choose supplier A or supplier B, we might consider not only the average delivery time for each, but also the variety in delivery time for each. Okay, so measure variety, range, interquartile range, variance, standard deviation, coefficient or variation. Okay, range. The range of data set is the difference between the largest and the smallest data value. So range is equal large value minus smallest value, and it is smallest the measure of variety, and is very sensitive to the smallest and the largest data value. So the range, you can see we put is the ascending order. Okay, so the largest one and the smallest value, okay, is 714 minus 525 is the 190. Okay, this is the range. Okay, so the next one is interquartile range. The interquartile range of data set is the difference between the third quartile and the first quartile. So it's range for the middle 50% of the data. It's overcome the sensitivity to extreme data value. Okay. So interquartile is the difference between the third quartile and the first quartile. So you can see the third quartile and the first quartile. So the third quartile minus first quartile, we can get the interquartile range. Okay. The next one is variance. The variance is the measure of variety that utilize all the data. It's based on the difference between the value of each operation and the mean. And the variance is useful in compare the variability of two or more variables. Okay. And this is the formula. Okay. So variance is the average of the square deviation between each data value and the mean. So you can see the variance is compute as follows. Okay. The first one is for sample, and the next one is for population. So you can see some difference. Okay, the next one is standard deviation. the standard deviation of the data set is the positive square root of the variance, and the image in the same unit as data make it more easily interpret than the variance. Okay, so this the standard deviation is computed as follows. So you can see this standard deviation is the formula. Okay, the next one is the coefficient of variation. The coefficient variation indicates how large the standard deviation is in relation to the mean. The coefficient variation is computed as follows. Okay. So now it's just to know some concept, and later we run the SPSS. We don't need to calculate by hand. We can use in the computer. Will show you how to get the number. Okay. Okay. So this example apartment rent, you can see the variance, standard deviation, coefficient of variation. Okay. So this is the example. Okay, so now we continue to talk about the population and the samples. So what's the population? The collection of units, and be they people, and maybe plan, city, okay, to which we want to generate a set of finding or statistical model, and the sample is smallest collection unit from the population used to determine truths about the population. Okay, so population is the size bigger than the sample. And sometimes some master student, maybe they have question when they want to collect the data, is because the population maybe is too large, and maybe we in the population we choose the some maybe they can do the interview or collect the data. Maybe we choose the sample. Okay, so you can see the outcome. Maybe they have the error because sometimes they have some maybe something maybe a change, also maybe have some error. Okay, the next one is a simple statistical model. In statistics, we fit model to our data. We use the stick model to represent what's happening in the real world. So in the research, maybe we have a research methodology, and we come out to some theory, and this is you can call a research model. And then the mean is hypothetical value. It doesn't have to be value and actually exist in the data set. Okay. As such, the mean is a simple statistic model. Okay, so the mean. Okay. Okay, so the mean is a model of what happened in the real world. A typical score is not perfect representation of the data. How can we assess how well the mean represents the reality? Okay. So this is why we do the research. We want to know the real world situation, and we choose the sample to do this research. Okay, so you can see the perfect fit is we get the same rating. Okay, and we have the error in the research outcome and the model. Okay. and the sum score error. So we can see the total error. Deviation can cancel out because some the positive other negative. This is the we call the sum of square error. And the mean square error. Okay. The sum square is a good measure of the accuracy of our model. It depends on the amount of data collected. To overcome the problem, we use the mean square error. Okay. And another one, degree of freedom. The left side you can see this the sample, and this is the population. Okay, and the next one, the standard error. Standard error tells us how well the mean represent the sample data. Okay, but if we want to estimate the parameter in the population, then we need to Okay, so now we can do the example, and then the next we can have the practice. In we previously we talk about the means and the median mode, this kind of maybe the quartile. This we can do. Okay, so let's continue to do this example. This is the apartment rent. This is the 70 efficient apartment were randomly sampled in a college town. The most monthly rent price for the apartment are listed below in ascending order. So you can see we have the 70. So we can see the question. So we can compute the mean, median, mode, and compute the minima and the maximum number, and the mean variance and the standard deviation. And the next question is the first and the third quartile. Okay, so let's find the data. So you can find the data in the folder he have is the name is apartment rents, this SPSS file, and you open, and you can see the variable view is have one variable apartment rents. Okay, did you find it? Okay, so let's do the first question. Okay, so let's go to the analyze and the descriptive statistic and the frequency. Okay, so we choose the apartment rents, and we choose the statistic. Okay, so we can choose the mean, median, mode. So we solve the first question. So we can we click continue. Okay, so we can see have the several table. This one, we can see the mean is the 190, and the median is the 175, and the mode is the 150. Okay, so you can see we have the 70. 70, and you can see the here the some apartment the rent is the same. Okay. Also, you can see the percentage and the cumulative percentage. Okay, so let's go to the minima and the maxima number. Okay, you can see the minima, maxima is the, we can check this one, and we can descriptive statistic frequency, and we can find the minima, maxima. Okay. Okay, so we can see the minima is 125 and the maxima is 750. And another way you can see this table in the is the ascending order. Also, you can see the smallest one is the 525, and the largest one is the 750. Okay. Okay, so let's go to the third question. Compute the mean, variance, and the standard deviation. So the same, we go to the analyze and the descriptive statistic and the frequency. And we choose the statistic, and we can choose the standard deviation, variance. Okay. And also we want to get the mean. Okay, so we choose the 3 and OK. So you can see it's very easy to get this kind of number. We don't need to calculate like we talked about before the formula. Okay, so the mean is the 190, and the standard deviation is the 54.737, and the variance is the 2996. Okay. Okay. Any question? Okay, so you can see the next question. Compute the first and the third quartile. Also, we can go to the slide. Quartile. Okay, so we can see the first quartile is the 20 percentile, 25, and the third quartile is the 70 percentile. Okay, so we can go to the SPSS. So we go to the analyze and the descriptive statistic, the frequency. We'll go to the, can see the percentile, and the first one. Okay. First one, we do the first quartile. So this is the 25. And the 8. And also we want to do the third quartile is 75. So 8. Okay. Okay, so the continue. So you can see the 75 quartile is the 625, and the 25, the first quartile is the 555. Okay. So it's very easy. We use this one. Okay. So we don't need to calculate by hand. So, and also we can calculate the range. You can see the statistic. We have a range. You see the range. Okay. Range. Okay. So we can continue. So we can show the range 190. Okay. Okay. So any question? Okay. Okay, so let's do the next example. Okay, so this example is about the result of the search to find the least expensive round-trip flight to Atlanta and Salt Lake City from 14 major U.S. cities are shown in the following table. The departure date was June 20 to 2020. 12 and the return date was June 27, 2020 and 12. Okay. So this is the table, and we want to this question where first one is compute the mean price for the round-trip flight into the Atlanta and the mean price for the round-trip flight into Salt Lake City. Is Atlanta less expensive to fly into than Salt Lake City? If so, what could explain this difference? And the second question will be compute the range, variance, and the standard deviation for the two samples. What does the information tell you about the price for flight into these two cities? So this is the second example. Is the procedure is the same as the first example we do in the apartment rents. So let's go to the with file folder, and you can find the file.sav expire. So we open it. So we can see the file, the data. We create the two variables. First one is the flight to Atlanta. This is the round trip. The round trip cost, airline ticket, the cost, and another one is the Salt Lake City. Okay, so we see the data. So we have the two column, and we have the 19 major city, 14 major U.S. cities. Okay. So now the first question. Compute the mean price round trip flight into. Okay, mean price. Okay, so let's go to the analyze descriptive statistic and the frequency. First one. Okay, so first we do the Atlanta and the statistic, and we want to see the mean price. Okay, so you can see the mean price is 356. Okay, so we can do another one, the Salt Lake City. So maybe we can put together. Okay, so this one we can check what's the difference. Okay, so you can see the table. So the Salt Lake City is larger than the mean price is larger than the Atlanta. So Salt Lake City is 400 $95, and the Atlanta is the $356.72. Okay, so the Salt Lake City is more expensive than the Atlantic City. Okay, so this is we can see the question A. So Atlanta is that expensive. Okay, so this is yes, and there's a difference. We can compute this one, and the 400.95 minus 356.72. Okay. Okay. And we do the second question. Compute the range variance standard deviation of two samples. Okay, so we go to the analyze descriptive statistical frequency, and we click first one, and we choose the range and the variance and the standard deviation. Okay, and we continue. Okay, so we can see this table, first table. So the flight to Atlanta is the standard deviation. This one variance and the range is 290, and the flight to the Salt Lake City, the range is the 458.8. Okay. Okay, so these two examples is that it's very easy to, if you want to run, if you run the SPSS, it's very easy to get this kind of the mean mode, like this kind of information. Okay, here let's do the next example. Okay, the question is the cost of the consumer purchase such as a single-family housing, gasoline, internet service, preparation, and the hospitalization were provided in the Wall Street Journal. Sample data typical of the cost of the tax return preparation by service such as HR block are shown below, and this is the cost of the consumer purchase. So you can see the computer mean, median, mode, and the computer first and the third quartile, and the computer and the interpret the 90th percentile. Okay, so before this we need to type the data, because we need to practice how to type the data into the SPSS. So you open the SPSS folder, the program. So we need to create the variable. The variable we call the cost of consumer per, maybe we call the cost of purchase. Okay, no decimal. maybe we can call the cost of consumer purchase. Okay. After create a new variable, we need to type the data. Okay, 20. Okay, 110, 115, 160, 1 okay, 150, 5, 195, 155, 105, 360, 120, 120, 140, 100, 115, 180, 235, 255. Okay. So this is the 20 cost of the consumer purchase. So now we want to do the first, compute the mean, median, and the mode. Okay. The same as we do the previous example. Go to analyze, descriptive statistic, and the frequency. Okay. So we choose this variable and click, and we choose the mean and the median and the mode. Okay, and the continue. Okay, so in first table we can see the answer. Okay, so mean is the 130, median is the 135, and the mode is 120. So in the data you can see the mode 120. You can see we have the, okay, so we use the 100E. So maybe we can try this one. You can see the 120 have 3. Okay, so this is the mode. Okay, so we go to the next question. Compute the first and the third quartiles. And the first quartile is the 25th percentile, and the third quartile is the 75 percentile. Okay, so we go to analyze descriptive statistics and the frequency, and we choose the statistic. So you see the percentile. First we do the first quartile. This is the 25 percentile, and the third quartile is the 75. Okay, and continue, and okay. So you can see the first quartile is the 25 percentile is the 150, and the percentile is the third quartile is 75. This is the 191.25. Okay. The next one, compute the interpret the 90th percentile. Okay. So this compute the same, analyze descriptive frequency statistic. We choose the 90th. the 8. Okay, so you see the 90 is the 253. Okay. Okay, so today this three example is the I think is the you can you can understand what's the like this kind of the concept, the mean more this kind of concept. So next week we will go to another topic. So see you.